So we're just going to go through another couple examples here. So this is actually a mesh that I had asked a student if I could use as an example, because it's a pretty cool mesh here. I like the look of it, but there's some serious issues with how it was modeled. So as we can see, we got two meshes here. They look pretty much identical. This is the student's version, and I'm sure you can already see a lot of the issues here. And this is the optimized version that I ended up creating based off of this specific model. So if we go back over here, we can see several areas where there's issues. We have edges running all the way through where we wouldn't be using this for vertex blending because it's not equally paced. It would end up with some really wonky looking vertex painting. We got edges here that aren't affecting the silhouette at all. They're kind of getting wonky and messed up here. We have a triple bevel on these edges here, which we saw earlier. A double would work just a single would work just fine. This is actually a double. It's triple edge, double bevel. A single bevel would work just fine for that. These edges can be removed. These edges aren't necessary. We're getting edges that are tied off to stuff here, and then this back face is a whole other thing. So if we actually click on this, we can see that he had taken his mesh and extruded this and then merged it, but it's all part of the same mesh, and it's just really, really ugly. And I'm sure this caused a lot of issues with UVing. I'm sure this caused issues with light maps, with just general rendering of this. I'm sure there was a lot of problems here. And then we see, he's got these double bevels here, but then here where a bevel would be great, there isn't a bevel at all. Not only that, with all of that being said, we can also look at this thing. This is a 2,280 triangle wall here. That's not terribly high for a modern engine. I mean, it's pretty high, but it's not terribly high. It's not super crazy, but for the shape that we're getting here, we're not getting 2,280 triangles worth of fidelity here. It does not need to be this high. This specific shape, this specific design doesn't need to be remotely this high, and we can see that with the optimized version. Again, looking at these two, they look almost identical, and if anything, this one looks a little bit better because we are getting that bevel here where we weren't getting it here, yet this one's 2,280, this one's 676. And this might even be able to be pushed a little bit further if you really wanted to optimize the ever-living hell out of it. So something really interesting to look at here is we take this guy, we look at this guy, we take this, this triangle value here, and let's bring up in the calculator here for a second. So this one's 2,280 triangles, okay? And this guy is 676. So we're gonna divide this guy by 676. I can use well over 3 of my optimized mesh for every one of these guys, yet still have just as high quality looking a mesh as the original student version that we have over here. If you turned in this to an art director at a studio, they're gonna give you some really wild looks because this is just not how models are made for games. This is very inefficient, and it just shows a lack of understanding of how models are made for games and how to optimize your geometry. This will give you some really weird looks from your art director. This is probably going to give you a pat on the back. Let's look at one more quick example here. So let's take a look at this guy. We got 2 of them here. This one on the left is, again, how I would see it modeled by a fair number of students. And it almost looks here like we could maybe say, well, this could be used for vert blending, and some of these could be, but these double edges aren't required. Having them run through this isn't required. And we got some extreme bevels to get that, smooth look that we know we only need a single bevel to accomplish kind of the same look. And if we go inside this guy, we can see that we got geometry here that's all really kind of mangled and bad, and it's just not looking very good. This guy is sitting at around 5,000. Now, I went a little extreme here to kind of prove the point, but unfortunately, I've seen this many a times in different student work, and this just isn't necessary for games. So we have this over here on the left, and then the optimized version on the right at 136, 5,034, 136. And again, from a distance, and even when you get kind of up on it, there really isn't that discernible of a difference. The main thing that I notice is the fact that this is set in, but that's just because this is modeled slightly differently in terms of the actual form. And that's okay, because it actually looks a little bit better in this instance, because they wouldn't really sit directly on top of each other, because you could have some Z fighting going on. So let's look at this guy. So on this guy, we have all those bevels and all that stuff that really are chewing into our geometry. Again, we're able to get very similar looking bevels with just a single bevel, a double edge. Same thing on all these bars. And when we go inside and look at this, we can see that it's all been, actually, it's going to be kind of hard to see because of the way that I did this. So we can see that this is one single mesh with a single flat plane in the back. And then we have these guys, oops, here as the bars. Oh, I forgot one. There we go. That, you know, have all the edges and faces removed that don't need to be there. And they're just kind of intersecting and sitting in here and then placed on top of that. So like we did with the mesh before, let's bring open this calculator. Again, this is a little bit more of an extreme example, but it's still, I've seen very similar things to this in the past. So we'll take this, and it's 5,034, and we'll divide that by, what did I say was here, 136? 136. So for every one of these guys, I can use 37 of these. Again, a very extreme example, but these are the kinds of things that we want to look out for. We don't need this to be modeled in this way because it's terribly inefficient when we can get the same look, and arguably maybe even a better look, for significantly less, and your game engine is going to run better, your scene's going to perform better, everything's going to look better, it's going to be easier to UV something like this than something like this, and it's just all around a more improved experience. So what I hope you guys can do after watching this is kind of take some of these ideas and keep them in your mind when you're modeling, when you're creating your assets. How can you still get the look that you want, still get the nice bevels, still get the shapes you need, not have a bunch of faceted stuff, but just kind of remove the extraneous things that you don't need, the edges that don't serve a purpose, the faces that don't serve a purpose. What can you remove from your mesh to bring these down to be much more performant without sacrificing the fidelity of your mesh? So I hope that all makes sense to you guys. But these are the kinds of things that you should be keeping in your mind as you go through and make not only your assets for these classes, but anything that you create from here on out, especially within a game engine environment.